Okay, good evening. Welcome to
FamilyMath number 603.
FamilyMath603. So, you were doing some work in Art of Problem Solving's Introduction to Counting and Probability book today, and you came across this interesting problem in Chapter 5, and this is about distinguishable cases and indistinguishable cases. So the first question was, how many ways are there to put 4 balls in 3 boxes if the balls are distinguishable and the boxes are distinguishable? So we're going to say our snap cubes are the balls.
Okay.
And we're going to say these cups are our distinguishable cups. Okay? I guess they look pretty distinguishable.
Yeah.
All right, now you know how to do this problem, right?
Yeah.
Okay, you have not done this problem, right?
No.
All right, so how many different ways? So why don't you work on this one?
Well, so we could start. Well, you always have to choose one box to have 2 things in it.
That's true.
So.
Do you know why that's true? Do you know there's an interesting principle of math that tells you why that's true?
There's only 3 boxes, and you have more things than you have boxes.
That's right. Remember what that's called?
No.
Do you?
The pigeonhole principle.
Yeah, that's right. That's called the pigeonhole principle. So you're right. At least one of the boxes is going to have 2 or more balls. But we're trying to figure out how many different ways are there to put these 4 balls into these 3 boxes.
Well, so you could, let's see. So you could, let's see, you'd have to use choosing numbers here.
Okay, what do you have to choose in this problem?
You have to choose, I guess you have to choose, you have, I guess 4 slots. So you have 1, 2, 3, and 4. You have to choose the places where they go, these balls.
Well, not quite. I mean, you can think about this as, because they're all distinguishable, you can think about these one at a time if you want. So what choices do you have to make when you're putting these balls into the boxes?
Well, you have to choose which one.
Okay.
And you have to choose, every time you have to choose one ball and then which one to put it in.
Okay, so how many choices do you have each time?
So you have 3.
Okay.
So, and then, and I guess there could be more than 2 balls in each. There doesn't have to be one in every one.
That's right, there doesn't have to be one in every one.
So, so you have 3 choices where this ball can go.
Right.
You have another 3 where this one can go.
Okay.
Another 3. And you would have another 3.
All right. So how many different ways are there to put 4 distinguishable balls into 3 distinguishable
So there would
cups?
be 3 to the 4th.
Which is?
That's 81.
81. Okay, very good. Do you agree
Yes.
with that? Okay. High five. Good work. Phew.